You're listening to Raiding the Fringe with Poda, Ostinius, Nehpets, and Dr. Lee. From ancient civilizations to the cutting edge of science, from exploring the outer reaches of space to the Atlantean depths, we discuss the topics of the unknown and the possibilities of the bizarre. Are you hungry to expand your horizons? Come get your fill as we raid the fringe.
Well, welcome again to another episode of Raiding the Fringe. Here we are with Ostinius.
Hello.
Dr. Lee.
Hello.
Poda.
What's up?
And myself, Nehpets. So today I think a good topic that we could consider about talking is the heavens, the universe, the planets, things of that nature. You know, we used to have 9, now we have 8, then we could possibly have 9 again. Who knows? There's a belt. There's all kinds of things out there. So anybody would like to pick it up from here, or I can continue talking about the random anomaly in the universe we are.
Do you know why the solar system has a belt? Because it's getting fat.
Because it's ever expanding.
You know, thinking about talking about the planets in the solar system and stuff, I was kind of at first just thinking about that stuff that I learned in school, but you know, they know a lot more nowadays than they did when you were in school.
And truth be told, I don't even remember what they taught us in school, because they start when you're in like, what, 3rd or 4th grade to teach you the basic, solar system.
Well, okay, so we got the sun, Mercury, Venus, us, Mars, Jupiter, Saturn, Uranus, Neptune, and it was Pluto was the official next planet,
Well,
but it's not anymore.
Well, I think that's weird, because they said Pluto wasn't a planet because it was small, and the weird orbit made Neptune the farthest planet, and then Pluto, and they did a little swippy swap.
Actually, it's a little bit more than that. So what they didn't teach us in school was first of all, no one talked about the asteroid belt very much. It's between Mars and Jupiter, I think.
Yes.
Yeah. And the asteroid belt puts kind of a gap in between those two planets. Now, I'll get back to that, but there's a second belt just outside of Neptune.
Well, wait. Okay, let's go back to the first belt. You're talking there's an asteroid belt deriving the planets from the gravitational orbit of the sun?
I'm saying that there's a missing child in our heritage. Between the two planets, there is a strip of asteroids orbiting the sun.
Okay.
And it's where another planet might have been. The reason the asteroids aren't throughout the entire solar system is because of the gravity. Once a planet achieves a mass to where it becomes a planet, it becomes hydrostatically stable, then the gravity of it either pulls other rocks towards it or flings it around like a sling and shoots it out of the way. That's why our planet's orbits are generally clear.
Okay.
Not 100% clear. We've got
but yeah.
But anyway, without that planet in that specific distance from the sun, that ring is left to be allowed to gather or to keep all of its asteroids flying around, unless once in a while they might collide or their own tiny little gravity flings them off, and when we get some of our comets. There is a dwarf planet in that space that is the same size as Pluto, and it is, let's see here, make sure I get them confused. Ceres is a little smaller than Pluto, but it is planetoid. And it goes under the dwarf planet classification. Now, because they found this, and they found several others in this other belt called the Kuiper Belt.
Okay.
Kuiper Belt sits just outside of Neptune. It's like the asteroid belt, only way bigger. Kind of a donut shape around. It's not flat like most of the orbits are, but it's thicker. And in that belt, there are tens, 20s, hundreds of objects that could be planets like Pluto being one of them. Its orbit is so odd because it is staying within that Kuiper belt, even though it's orbiting, but it's not limited to its own orbit. It's orbiting with the rest of the belt. It also has, it's got several moons, and its biggest moon is so large, it's like 2/3 of the size of it, that they are binary. Pluto doesn't revolve. It spins around its moon while its moon surrounds it, so they do a little waltzing dance as they go around the sun. Another reason that it shouldn't be its own planet. It has nothing to do necessarily with the fact that it's only half the size of the U.S., as far as planet size goes.
It's that it's already on its own spinning course to devolve.
Well, if they made that a planet, they would have to make the other one a planet too.
Correct. Yeah. Actually, there's about 10 other ones they'd have to make a planet for sure.
Well, then, what defines the planet specifically by their parameters right now? Not size.
Okay, it has to have achieved hydrostatic equilibrium. That is, the pressure inside is equal and balanced out with its gravity. So it's a solid ball. It can be oblong shaped. That doesn't matter. But the thing is it's not expanding anymore and it's not contracting anymore. It's found its happy zone.
It's already hit critical mass or whatever.
Right. It has to have a regular orbit around a star.
Okay. Well, because the denominator would be a moon. They find their orbit around each individual planet, right?
Right. I forget the third criteria. The third criteria was the clincher, too, that they really made them declassify Pluto. I believe that was because it doesn't hold its own mass-centric. Its center of mass is technically outside of it because of its moon, Charon. But the thing is, the Voyager 1 and Voyager 2 have both recently passed Pluto and gotten to take good close-up pictures. For the first time, we got to see what the surface looks like. And they have seen so many interesting features on the surface. There's a whole ecology going on. There's a nitrogen sea over the surface, and there is icebergs of water ice floating on this sea, and proof that most scientists find solid that underneath that surface there is actually flowing liquid water. And there's so much interest on this surface and with the way it looks, and it's got a giant heart-shaped glacier that takes up like a third of its face. They want to up it back to planet status. But the problem is, and the argument is, if they do so, they have to for all these other planets.
When was Pluto discovered?
1930.
Really?
Yeah.
So technically, for most of our human existence, Neptune was the last planet.
Well, for most of our existence, I think Mars was the last planet.
Well,
they couldn't see that far out.
I thought they could see Saturn for a pretty long time.
Yeah, exactly. There were, Venus is
you're right.
prominent in the sky.
That's what I'm saying. Like, when was, they'd be like, okay, we're going to name this Pluto. You know what I'm saying? Like,
right.
We've been looking at the stars, and we've noticed that those stars didn't move exactly like the other stars did. You know what I mean? So we named them planets. So I was just wondering, did they find Pluto back then, or was this a recent discovery?
Yeah, no, it's the most recent of the original 9, as it were.
But that still goes back to 1930, which is to say that there's lots of room for more speculation and more.
But it would make sense
these
how they
exoplanets, you know what I mean?
How they would mistake one of these planets that are an asteroid belt for a planet. You know what I mean?
Yeah.
But at first it was the other way around, I think, and that's why it took so long to even find Pluto in the first place. It is so small and so far away that no one was able to see it. And then Kuiper was it was after Pluto had been found, but Kuiper theorized that Pluto isn't by itself out that far, that there is this whole surrounding of other smaller objects, much more populous. They called it the Kuiper Belt after him, even though he didn't discover it. He had only theorized about it, and they didn't discover the belt until later.
Right. But there was indeed a belt.
Yes, there was indeed a belt. And it goes past that, too. There is a cloud. Outside of the Kuiper Belt, there is what's called the Oort cloud. And it is filled with even more asteroids, possibly dwarf planets.
Okay, so
and such. And it's not a belt. It's a sphere. It's a ball that surrounds us.
But us even going to that dynamic, are we assuming that there is life?
Well, I'm not even going with that. Does every sun or star have this type of...
like a solar system?
Like physiology of it, like how it would have a bunch of the cloud thing around, like encompassing around it all.
To one degree or another, yes.
Okay. So is that a way that, can give stabilization inside that? Kind of like a gate or a fence? Or is stuff too spread out by that point that it...
Actually, it's funny that you ask that. What scientists commonly call as the heliosphere, it's basically the sun's atmosphere. It goes to our solar system all the way up to this Oort cloud. And the space is filled with lots of radiation, plasma flying everywhere, and the sun has its own radiation. Its radiation extends outwards to the edge of this Oort cloud, to the end of this heliosphere. And the fact that it is shooting out from the sun is protecting us from cosmic rays. It creates a bubble, this Oort cloud. It is, to one degree or another, just like around all the other stars. But the Voyager satellites that have gone out past Voyager 1 just last year, just passed the outer reaches of the heliosphere into the Oort cloud, where all the radiation tripled instantly, and it's getting bombarded by space radiation. And so it was confirmation of what scientists had already assumed. So if you think about it like water down a drain, and where the water hits the sink is the sun, you'll notice a ring around the sun where it looks kind of clear before the water kind of bubbles up and tries to go down the drain.
Right.
That is what our solar system is doing in that heliosphere. Inside, it looks smooth and nice, and it's the space that we all know and love because of the sun's radiation, the solar waves, keeping everything good for us. And outside of the termination shock, that's what they call the outer boundary of our bubble here, right before the Oort cloud. That's where you get the turbulent, what the fuck is this radiation coming from everything.
Okay, I have a question about these things, the Voyager and things like that. So, we just basically shot this thing out into space. And did we calculate exactly where we wanted it to go, or is it just free flying through all this stuff?
No, there was a calculation on the trajectory of where to shoot it out. So they knew approximately where they wanted it to go.
Oh, they had a no more than approximate.
Because you got to think it has to go through an asteroid belt. It has to go through what time the planets are going to be there.
Right.
So when it goes through this heliosphere, which you said at first went through there, we knew about it, but did we actually have the calculations to make it to where we would feel confident that it would get through that without being busted up?
I think that it was a tool for knowledge, because initially we shot out blind, and when it happened, you gain knowledge from that initial launch. It probably wasn't for a while, right?
When they launched it with the intention of going to Pluto. That was the intention. In fact, the only way they knew to achieve it was they intentionally shot it past Jupiter, using Jupiter's gravity as a slingshot to throw it even further so that it could finally make it out there. Once it passed Uranus, it went into a deep hibernation mode so the power wouldn't falter on its way out, so that way it could still be structurally sound enough to reach Pluto. Pluto was the ultimate goal for it to start with, and they used a lot of calculations, nowhere near a shot in the dark.
But now that it's past Pluto and into this heliosphere, now it's just... let's see how far it goes.
Right, because once it got to Pluto, they're like, oh, you know what? This guy's doing great. He's not even near dying. Let's let him run. Let it ride, buddy. And so they left it on, and they sent it to go on even further and see how far they can go. Their next step was to break that barrier. And now that it has, they're still going to let it go. Like you said, they're just going to see how far they can take it. And the Oort cloud that it's reached is estimated between 25 to 50% of the way to Alpha Centauri. It's almost halfway to our next star. So we have officially entered interstellar space travel.
In a sense.
It's not manned.
Well, yeah, but when did we release this rocket? When's that? What year was that?
Yeah, when was the first thing? You said the 30s or something?
No, for the Voyager to be sent out?
No, he said that was when Pluto was discovered. But when was Voyager actually?
Yeah. When are we talking this thing that's past the Alpha Centauri?
Sorry, weren't expecting that question.
Yeah, the baseline.
I'm just saying, we could know. How many years did it actually take to get to Pluto? You know what I mean?
Yeah, I
these are regular years. Obviously, we're not going light years.
I believe it took 6 years.
That's still
no, because I think that they said there was.
It is damn fast.
It was
like
5 years to get to Mars. Well, in a manned craft.
You got to think this is smaller, but I mean, still though. So thinking 6 years to get to Pluto would be crazy.
Yeah.
77.
77. So
77
when
years.
were you born?
78.
That's longer than Halley's Comet comes to whip around. You know what I mean?
That's like 80 years for Halley's Comet, right?
Halley's coming to 75 years.
Same crap. Yeah.
Mark Twain.
We won't.
Not 77 years, 1977.
I never got to see it.
Well,
you never got to see it.
I'm
You never
saying
will.
Halley's Comet is
You
75
did.
years.
Mm-hmm.
You got to see Halley's Comet, but me, you, and Poda probably didn't really see it.
Hell,
Yeah, my eyes aren't
86.
that good.
It came out 86.
if I did see it, there's no way I'd ever remember.
I just know because it was on my birth year. So I'm never, unless I make it to 75. But no. Okay, so
Yeah, both Voyagers were launched in 1977. So it was a lot more than that 6 years. I don't know where I got 6 years from. Maybe it was 6 years from Neptune to Pluto.
that could be, but still, I mean, like 40 years, that is a person's, half a person's lifetime to get to the end of our.
Well, did you
the end of
ever
our
see
thing.
the study that there were, like, each planet has its own sound? They put out radio waves because that is responsive a little bit quicker than visual contact to a satellite.
No, I've not heard about it, but if you'd like to go more into it, you can.
Yeah, I'm not. I mean, I might have heard something about that, but I still don't understand how sound can move faster than light, because it generally doesn't. So,
Oh, I see what you mean.
Well,
It's
no, but
easier
it
to
would
break
still.
the sound barrier.
We would still get the sound right now because we've seen the planets. So then we would have the technology to hear the planets. You know what I mean? Like,
Yeah. Like, I heard, like, Neptune sounds like an ocean, and Saturn sounds like a windstorm, like that kind of stuff.
Earth sounds like 7 billion crying babies.
so Poda, what's your favorite thing about the the heavens above us?
I don't know of one particular thing. I find it all very fascinating and interesting. The fact that the Voyager's trip just to get to Pluto, the mathematics involved, I think, is badass. The fact that it's now going out to where it is exciting because since they didn't plan to go that far, they don't know what's going to happen. I think it'd be amazing to have this last image captured of an asteroid about to hit it and destroy it. It would suck. It'd be destroyed, but it'd be a cool image. And as far as making it to another solar system, any information coming back from that device in my lifetime, I'd be listening to what's being said or heard or the data found because I find that interesting. As far but the number of celestial bodies out there, the clouds, the belts, the asteroids, the ice, the stars, the planets, I find it all fascinating. My memory sucks, so I really can't hold on to too much information once I read it, but those are some of my favorite documentaries. Even though there's a lot of documentaries out there about space that are pure theory and you just get cool cinematic renditions, as in the black holes or white holes and the effect of time, distance.
Well, I'm going to say this. Like, okay, so again, just thinking about it, we created something in the 70s that has enough power and life to last 40 years.
Right.
But
and
we
it's
can't
still
get
going.
things to have enough battery power in this day and time. So I just don't understand, like, what kind of technology are we using? Is this just radio waves, or is it, like, you said it's sending pictures and stuff, right?
Yeah.
So how long, I mean, like, okay, so a camera that essentially has been going for 40 years, right? Close to it.
Yeah.
And it can still send us pictures today.
Yeah.
So just like the technology. So what happens, just thinking how much the technology has advanced.
Well,
you're like,
the thing is, you
true. If we sent
also,
one out
like,
now, it'd be
as
so much
as the equipment goes further and further, we're looking at longer and longer response time. So even though maybe to the moon it took us 10 minutes for response time, now it's getting out past that point of Pluto where it'll be like 3 years before we get some pictures from Pluto. And then as it moves further out, we're talking like 5 years before.
I think as far as Pluto goes, it's more like a 26-hour response.
That's not bad for that kind of, you know what I mean?
Well,
26 hours.
That's kind of what I was saying about why I find time and space fascinating on the sense of how they work together. Because, like Nep said about the technology from 30 whatever years ago, still going strong out there now, with the travel and the speed and determination of gravity and light speed and relativity of time, what are the theories of if you leave and go into space for 2 years in this direction or whatever, you come back and everyone you know is older now or younger? Like, is that equipment that's out in space, even though it's been out there for as many years as we're aware, it's only had the wear and tear and actually been in use for like 5 years? Now, granted, it doesn't have the weathering effect that deal with like here on Earth, but there's still got to be micrometeorites or radiation.
I don't know of any study that's been done personally that when an astronaut goes up into space, they come back and time is different.
Yes, there have been many experiments like that. You age less in space.
I would say that because you don't have as much stress on the body like gravity and things like that, that's why you technically age differently.
That's precisely what that study was about.
Yeah.
But it's not going to be like
of gravity and
it's
pressure.
not going to be like a Rip Van Winkle thing where you go up into space in 2 years, come back down, and then all of a sudden
you're like a fraction of a minute
That's
younger.
my granddaughter.
What I think Poto was referring to, though, is with the theory of the speed of light and relativity, the closer you approach the speed of light, the more time actually slows down. So if you are traveling the speed of light, time is almost frozen for yourself. And so if you traveled for 2 years at the speed of light and came back home, still traveling the speed of light, and then stopped and saw what was going on, you would not have aged, but 2 years would have passed in the world.
Yeah.
Okay, so how fast are we getting this Voyager?
Nowhere near the speed.
No, I know. I was just asking, like, how fast is it going?
5G. 500,000 miles.
If I have these questions, maybe
per
our viewers
hour,
would have these questions
Sure.
too. You know what I mean?
Well, I agree. I have no idea.
500,000 miles per hour.
11 miles per second.
No, that's fast.
That's faster than what I said.
That is fast. 11 miles per second.
So how much is that per hour?
How many seconds in an hour?
About $8.75 an hour, I think, minimum wage.
39,000 miles an hour.
Oh man!
Now this can be. So is that the idea of like this can be achieved because it's an unmanned thing, or could we take a manned thing and put a man in a thing and go 39 miles?
Well, there's a certain point where there's a reckless abandon because it is unmanned. If it crashes into some random asteroid, we don't want to lose that money, but we'll be happy about the data.
Yeah, if we put anyone out there, it's a death sentence.
Yeah, but again, just thinking.
Yeah.
There is a lot of stuff in space and trash and things like that. Like space trash.
Debris.
You know what I mean?
Yeah.
But it's clear, essentially, right? Like you said, because kind of like a vacuum and these planets. It's clear. So we would be able to go from here to Mars, wouldn't we, without any kind of real asteroid like thing?
No.
Even in the asteroid belt itself, the concentration of asteroids, each asteroid is tens of thousands of miles apart from each other. There's
crazy.
Plenty of maneuvering space. It's not like in the movies where they're all like you have to maneuver around them and such. These asteroids are so spaced out that it is easy to get through without worrying about running into one. As long as you've kept an eye on the sky, you can actually see most of the asteroids anyway, unless they're too small.
I have to agree with that.
Okay, so again, earlier this week we had a post from one of our members here about that different ways that planets are that are kind of freaky or goes against what we think planets are.
Yeah.
I personally didn't have time to watch it, so would you care to explain a little bit more about it?
Oh, yeah, that article is mostly on exoplanets. Exoplanets are planets in other solar systems, not ours.
But close enough to ours to be observed.
Well, obviously, otherwise we wouldn't have observed them.
Well, exactly.
But our technology has advanced so far that we've got imaging of these planets, and some of them get really crazy. The scientific search, we're looking for a planet like us. We want to prove that we're not alone in the universe. And amongst these planets, they've found so many curious factors. There was a planet made entirely out of diamond because it's a carbon-based planet, and the pressure is so hard or so great that the entire thing is a diamond, and it sparkles in space.
That's cool.
There is another planet that scientists actually call Waterworld, and it is an ocean of H2O, and the planet is a big old water drop in space, literally. It's nothing but ocean of water. The core is water, but it's under such pressure that it's become ice again, but the island is pure water.
So there's no land on it whatsoever?
No land on it whatsoever.
That's kind of crazy to think that a planet's core could be so, condensed that it's actually ice.
Yeah. There's a planet that it's got a weird name. Some of these planets they haven't named. They just have their scientific
XLR 2020.
Yeah, 92b or whatever. And but they have found a planet that is 88% like Earth. They have an index, 1 being Earth-like and 0 being absolutely nothing like Earth. And every planet, they give a decimal in between to say how like Earth it is. And there's this one planet, it's 88% like us. It has continents, it has mountains, it has water. It looks an awful lot like Earth from the pictures. And I'm not just talking artist renditions, I'm talking about pictures. And if there is life out there that is the most like anything we'd ever see, 400 light years away. And scientists are so convinced that there has been a specific effort where they have targeted their array at that planet and send out messages. And of course, at 400 light years, it's going to be a long time before we hear a message back. But we're expecting to.
Why you burning up my phone, mate? They sound British.
We're sorry, but the planet you have contacted is not home right now.
That's kind of cool. I like to think that, there's all kinds of the different planets, because I never thought about that. We said there's different life forms, like a silicone life form, a carbon,
Mm-hmm.
But now thinking of the planets.
Off of those planets, yeah.
Yeah. I don't think much could grow on a diamond, but you never know.
Yeah, you never know.
Which is crazy.
Also, that's one example that we already know of gaseous planets that are perfectly made up of gases. So who's to say that every time we breathe in nitrous oxide when we go to the dentist, that's not a life form? Like, it could be. It could perfectly well be not something that we perceive.
Even closer to home, have you seen the Mars rover photos from this recent...
Like the bird or something like that?
The thing perched on the rock outcropping? Is that what you're talking
about? Not even
about?
that. Something flying through the atmosphere.
No, I haven't seen that one. I'm just talking about when this recent landing where they get sharing all the 4K footage and stuff. Just looking at the rocks and the formations and everything, it looks so Earth-like, even though Mars is so... Yeah. And it's such a red planet, but the sky is blue. And the sunsets are blue instead of red.
Yeah, that's what I was going to say. It looks like that, but then there are those anomalies that...
Well, wouldn't every kind of rocky planet kind of look like ours, you know what I mean? Because
the blue in the atmosphere is a reflection of water particles in the atmosphere, and that's why they say that hopefully Mars could be adaptable. Now, when the sunset is happening, us getting our golden and purple refractions stuff, that's us seeing more of the, for lack of a better word, chemtrails of the lithium that is put off by the sun blasts as coming down, and the refraction is what we see as those purples and stuff like that.
So you seem to know a decent amount about what we've researched, and stuff. So how much actual research have we done for Venus? The other planet right next door to us.
Oh, that's true.
The problem with Venus and Mercury is that they're really too close to the sun. We can't get near it because it's too hot.
Okay, so
we have done. We know the chemical compositions of the surface. We know the temperatures. We know how fast it rotates and revolves. But beyond that, the focus hasn't been so much towards Venus and Mercury, mostly because with the ever-expanding wanderlust of the scientific mind, we're always looking to go outward. And even though technically that's outward, once you start thinking on a scale of solar system, now you're like, okay, well, this is us.
Inward.
Let's look outward even further. And with the two planets being so hot on the inside that it can't support life as we know it. Who knows? There might be an energy-based creature out there that we haven't even tried to
but
detect.
also, so we know what the chemical makeup of the surface is, basically?
Yeah, and we know what the atmosphere is like on these planets.
Well, we have a basic knowledge.
Now, is this too hot for anything that we could create to go to, basically? Or how far can we send something towards the sun before it gets to the point where
we could send something straight into the sun.
Well, no, but before... no.
It's just making it survive, that's the
No,
trick.
I'm just saying before it critically fails. You know what I mean? Or... you don't get any information back from it or things like that nature. You know what I mean? Like, how far can we actually... because other than sending radio waves and, things from satellites, how far could we send a probe before it gets to the point where it wouldn't
We can get
work?
amazingly close to the sun. Like, we've seen solar flares and things.
Yeah, but that's through satellite imaging and stuff like that. Like,
well, that's us sending a satellite closer to the surface of the sun. Like, we can see things. We can go, relatively close to the sun.
Yeah, apparently the Parker Solar Probe has gone to within 3.8 million miles of the sun's surface.
Yeah, that's
we're about
close.
we're about 93 million miles from the sun.
so we could technically send a probe, like a rover, to Venus.
Yeah.
Yeah.
And I just don't understand why we wouldn't. I understand because we're looking for, places we could terraform. But, wouldn't you still want to... that's the next closest celestial body. Why wouldn't we study it just as much as the other closest celestial body?
We have sent a probe to Venus in 1962.
Oh.
The Mariner 2. And that's why we know as much as we do about Venus. But closer to the sun than even Venus is Mercury.
Have we been to Mercury, then?
I went to the Mercury dealer once. Got a nice car.
But, just an idea, did we just find absolutely nothing on Venus, or just, screw it?
No,
we found a poisonous atmosphere and a really hot ground.
Yeah, we found that it is not viable for human sustainability. That's the better word. Shut up, Oda.
We have not sent a probe directly to Mercury yet. We did launch one in 2004.
That was when they were really messing up, though, because, that was like when they sent it to Mars and they put it in kilometers instead of miles, meters and stuff like that, and it crashed right into the planet.
Yeah.
So, but the messenger, that's what we're calling that probe. Which makes sense since Mercury was the messenger god.
Yep.
Okay. But, did we get there, or did something happen, or is it still traveling there?
Let's see here. The article I've got's a little out of date. Let me see if I can't find something a little bit more
That'd be cool
up-to-date.
if it's still going there, though. You know what I mean? We don't know yet.
We're still waiting for the Mercury capsule to get there.
Oh, I'm sitting there and what the crap do you want me to do?
Thanks. It had reached Mercury in 2011, and it stayed there for 4 years. So, yes, we have visited these planets, technically.
That's kind of cool. We don't know this. Still,
That's
common
not,
people.
Yeah,
Right,
it's not
right.
popular news. It's not as big as the Mars rover. And
I guess, but it still is
Even
just as
the moon
important,
landing.
I feel, because...
yeah.
Yeah, well, Mars, it fascinates the imagination because of Martians, because of the whole rage of the fact that this planet is the closest to us and the closest like us in our solar system, that it triggers the imagination of the layman. And so when you hear about the Mars landing, well, first of all, that is a landing, not just a probe flying around it. So that's pretty exciting. But that's why Mars would be more exciting. We're looking for Martians. We're not looking for Venusians.
But more what Nep is kind of referencing is missions to the moon have been more publicized than those missions, and those were...
Well, that was in the,
possibly
60s and 70s. Anything out in space.
No, not even. There have been recent moon missions.
Yeah, but that's from China, too. They're not going to tell us crap.
Well, you're also talking about the International Space Station and stuff like that. That stuff has been more publicized than the mission to Venus or Mercury ever were.
And that's it, yeah.
The International Space Station, that is something. That is countries
It really
working
is.
together.
Yeah.
And how old is that thing? Like 80 years old?
Oh, yeah.
Like
it's been around.
It's older than a person's life. And like they sent that up, and I know it has to be repaired and everything, but so if we can do these, marvels, in the 60s, like I said, with the Voyager and, we do all this other stuff, it's just, I understand we don't give it enough funding, but...
Oh, the International Space Station's not that old.
How old is it?
98.
Oh, well,
really?
I don't remember. Crap, the 90s were a blur.
The first piece of the space station was launched in 98. Currently, they're still working on it, sending people from every country up there to work on it. And Tom Cruise is headed there.
That's
To live?
Yeah, no, not quite. He got clearance, permission, and money to go onto the space station to shoot a movie.
Oh, boy.
He got his NASA training, and he's passed, and he is headed out there.
Scientology, what it can do for you.
Yeah.
Rocket Man.
I'm glad I've got my Glaxorbs in order.
Tom Cruise is Tom Cruise crazy. Just be glad it's him, not you.
But again, so, what's the furthest we've actually recorded seeing? Like, let's say visually seeing, like with a picture. You know what I mean? Like, how far out have we seen?
Dude, there are pictures of like.
Well, no, I know, but I mean, like,
and like all sorts.
How
of
far
stuff.
have we pushed it? You know what I mean? Like, just to see what we've actually been able, because it's kind of like the waters. We don't know what's in the waters until we send probes and stuff. It's to our imagination. Like,
Yeah.
that's a lot of miles if that's how big.
That, sir, is 3.75 billion miles is the farthest object that we've actually gotten imagery of.
That
wow.
is insane.
Once you get past that point, there are still objects the scientists know about, and we can still know its size, composition, and all of that because of its
Based off
spectral radiation.
Yeah.
When you bounce light off of it, it splits in a prism and highlights specific bands of light.
Yeah.
Isn't that crazy?
Basically, once it gets to that point, we're searching for planets like we used to back in the day. And so when our technology gets better, it pushes it out, and then we're still searching for planets like in the 60s. You know what I mean? So that's kind of cool.
Then, okay, I got a question. What are you all's thoughts on the possibility of a giant tardigrade in space, a creature that lives in space constantly? Kind of like Galactus, could eat planets or asteroids, I don't know, but something massive that's actually a living organism that lives in what's considered the vacuum of space.
How massive are you talking about? There's things that are like beyond our belief of how big is out there.
Well, he's
like how
talking
big.
about devouring planets.
If it's big enough to devour a planet,
Exoplanet or real planet?
if it was large enough to devour even, let's say, dwarf planets, this creature would have to be huge, and there would be no way we could have not picked up on it somehow.
I don't know, man. Like, there's tons of
It would show up
space.
if
like,
we could see.
what happens if it's past 4.78 billion miles away? You know,
Yeah,
Well, that's what I'm
we're
saying.
just not-
It would have to be
Yeah, we're
that
not-
far out.
Yeah.
We could see Jupiter like at certain parts of the year.
Yeah,
we
but
would
it's still
be
just a
able,
speck.
We would be able to see it. Is what I'm saying.
Oh no! It depends on how close it gets to our solar
If
system.
it's 5 billion miles away, we aren't going to see it, and only in that circumstance would I even consider us safe.
But what I'm saying too is we haven't even mapped out every single spot in the universe. Like, we can only do it as pinpoints, kind of like shooting beams. We haven't carpeted the whole of our skies.
That's true.
So it could be closer. There could be something that big closer, but we haven't.
I
looked there
agree,
yet.
but the reason that we are able to pinpoint things is because there are those pins to point. You know what I mean?
Yeah.
Like, if this thing that was so huge able to just eat a planet would be exponentially bigger than something like Jupiter, and we would see it.
there is an exoplanet 3 times the size of Jupiter that we haven't seen, but
An
we just know it's there.
exoplanet. If there was
Because-
a big old tardigrade
because of
that
the-
would ate Jupiter, we would
Well,
see it.
That's what I'm saying.
That's
Well-
what I'm saying.
We could be calling it a planet, but it could be that body floating in space. That,
Oh, yeah.
because we don't have imagery yet, we're only guessing
And
off of what's bouncing off of it.
But
Makes
that's
it possible.
crazy. There's an
But,
exoplanet
it's
as
like-
big as Jupiter, because that's. I mean, Jupiter is just full of gas, right?
That's what I'm saying. I do believe, even though we have all this visual capability, we're looking on different parameters of visualization. these things could exist, but we can't identify them because we haven't tweaked the dial left or right in that direction, or used this different type of instrument to visualize and the data.
Yeah.
Yeah, basically.
I'm going to go out on a limb, and I'm going to say that planets are a lie. The only real planet is Earth, and we are the center of the universe. Everybody revolves around us, and any other extraterrestrial life can, quote unquote, with my fingers, suck it.
I've never heard that theory before.
Yeah, well, I'm posing it now.
NASA makes fake pictures.
Oh, yeah,
or
NASA
that could be a desert. Why does it look so Earth-like?
Uh-huh. Why does it look so Earth-like? Because it was Earth.
Because it was Earth.
Or if they send pictures of Europa and stuff, they just take satellite pictures, you know what I mean, of certain parts of Earth.
Europa, they tied a rope around a certain area, and that's where you could film in. That's Europa. Well, it's a truth of the matter, ladies and gentlemen. Sorry, this is all fake. Planets are fake.
Those are fake numbers, the 3.475 billion.
We live on our own moon disk.
Did you know a billion
That's
isn't
what
even
flat
a real number?
earthers are going for.
What's a real number anyways? Let's reel this back in, though. But we definitely learned a lot about things, especially our own solar system. I mean, originally when we were thinking about doing this topic, we were talking like, well, what really is there to talk about in our own solar system that, isn't interesting or is interesting? And you definitely brought some stuff to the table that, got me to question some things and stuff like that.
Can I give you one more?
Oh, yeah, of course. Why couldn't you? Can you?
It's small, but the heliosphere that I was talking about, the bubble that is basically our sun's ecosystem, isn't shaped like a ball. It's shaped like a comet. On one side, it trails off into a tail. Our solar system as we know it is a comet hurtling through space.
Oh.
So that could possibly mean that unless we've, studied comets that come close to us, but wouldn't it be kind of cool if every comet that comes close to us is its own little universal
it
solar
had its
system?
own little...
Oh, yeah.
You know what I mean? Because we look like a comet. If we look like a comet from something else, why wouldn't another comet-looking like thing be another solar system?
That's
Not saying that
I
the
agree,
sun,
scale.
you know what I mean, but on the scale that it was just that small.
The all of the comets that have the really long cycles, Halley's Comet being the shortest of them, the ones that take like 1,000 years to complete a cycle or whatever, they all think that these are systems that came from our Oort cloud around us, creating their own comet from being out there and eventually being drawn into the heliosphere.
Okay, so ultimately with
each
this
of those
thing,
outside of our thing could be tiny systems, like you were saying.
but each of this, like what you're proposing, is that we are ourselves jettisoning through space.
We are, in a sense, already, because we think we're part
we
of
say that the universe is ever expanding,
but like we're in the Milky Way system, so we're still moving, and things like that. It's just what it looks like. Our solar system moving looks like a comet, which apparently we now have the technology to see that.
Which, that is interesting. The universe is expanding, yet the center of everything that we're aware of that we're a part of is a black hole, right? So we're all flying towards it?
No,
but
we're all
the
flying
universe
from
is
it.
expanding?
We're all flying from it, yeah.
Expanding. The Big Bang sent us spinning
Now,
away.
I have a
from the
question
center.
then. When we look at other universes, like, because we can, right? We can look at other, solar systems, I guess is what it is.
Like other galaxies?
Yeah. Do we see the same aspect of them looking like a comet almost?
We see lots of similarities.
Well, there are those weird, spiral galaxies that mean that they're spinning towards the center. There are the ones that are nebulous clouds.
on the galaxy level, but as far as solar systems within the galaxy.
Okay.
Yeah, like the solar system. Because if our solar system
talking
or our
galaxy.
sun's ecosystem, or our sun's body, because let's just say our sun has a body and it's all the planets and stuff. Does every other sun kind of look like a comet going through space?
Yeah, it's kind of a kick to the ego, but we are not unique. There are so many systems out there that are close to what we've got going on. There are very many that are so dissimilar, and a lot of it depends on the size and type of the sun. If you've got a red dwarf, the heliosphere is going to be larger but cooler, so it's going to have different properties. And then, of course, you've got the black holes, which might have been a star at one point, but don't have a heliosphere anymore. Instead, they have an event horizon.
Yeah, may have gone supernova and now are doing the opposite pole.
Yeah, so a lot depends on the source star, the heart
I guess
of the
more
body.
like ours, our brand of sun.
But yellow giants. I think that's what we classify it as. There are a whole lot of them that we find similar things, and in fact, studying those has helped us understand ourselves because we're seeing it from the outside perspective, and theories are formed that our star is like their star, so our heliosphere must be like their heliosphere. And so that's when they formed the theories. And now, thankfully, to efforts like the Voyager program, we're now seeing proof that, we were right to do so.
Yeah, thankfully, with us doing our work with Project Blue Book, we've talked to the reptilians, we've talked to the Nords, and we found out exactly what is happening. I believe in aliens.
And before they rebooted the time loop, when we had talked to aliens and they decided we weren't ready and reset us.
Time loop.
Well, I think we definitely learned, at least I did personally, learned a lot more about our home area, you know what I mean? And we're still learning today, just going online and doing a little bit of research that we did just now, finding out these questions that I had pop in my head. We definitely, the information's out there, but, I think it'd be cool to learn more and to push this exploration a little bit further, because the more we know our natural area, the more that we can understand how things go. If you guys have any comments or anything, you can always email us and stuff. I know we say this all the time, but if you have questions, this was an actual real informative one. This isn't just we actually had some fun and did some things with this, and it's a little bit different than what we normally do, but hopefully you learned something. If you have any questions or any comments that we missed or we got wrong, just let us know.
Well, we'd like to thank you for joining us today's episode. If you'd like, you can directly contact us with any questions at ratingthefringe@brainforger.com. We'd really appreciate it if you would give us a like, share, or follow, and comment on any of the episodes that you've listened to. We're on Facebook, Spotify, or anywhere else that you get your podcast fix. Thank you for being here with us while we raid the fringe.